of escaping some question. Yeah, so I'll keep it short, and it's also lightweight, not too technical again as study is widely. So I will present a simple tool which we are developing part of our Green Liquid project, a dashboard. One of the questions asked by participant is how do we make researchers motivated to be considerate about the sustainability of energy. Part of the reason we can't motivate researchers, we don't have a tool for them to first know about what is happening their digital footprint. So maybe complement to that question, like how do we motivate them to know about their digital footprint? So it's a small tool. We are sending for different type of workload. Okay, so I'll talk about the dashboard tool and have a small demo, then some other development we are doing and I'll conclude that talk. Okay, in last 5-10 years, since the notebook have become more popular, started with some machine learning workflow, but now we want domain scientists, serious scientific use cases in biology, astronomy, or even you can see very sophisticated workflows have moved from simple bad jobs which were run on Slurm to Jupyter. A lot of people are adopting because of ease of programming and easy to start their workflows and then build more complex workflows on top of it. And the challenge comes with such a workflow. They are easy to use, but very hard to track what happens in the back end. I will talk about why it is hard to track. So we were developing a tool to how do we assess the environmental impact of such and workflows, which are based on Jupyter notebooks. So why they are challenges? They run unlike the HPC jobs, more or less done on physical machine. Jupyter notebooks run on virtualized environment. When you talk about different research infrastructure, some say we are running Jupyter in Kubernetes, some say we are running in standalone Jupyter Lab server, some are having their own virtual machine when they run Jupyter services, some even have the Docker infrastructure to run the different notebooks. So it's very hard to estimate the resource footprint when you have multiple deployment architecture and the KPIs and metrics in each of these software stacks, the way the Kubernetes captures, the way virtual machine captures, or the way Jupyter Lab captures, they are in a different granularity and different metrics you want to understand. More importantly, the Jupyter workflows are used by domain scientists, people from biology or physics. If we want to give them some sustainability metric, they would not entertain giving them some endpoint or here is a Prometheus metrics, go and find out how much utilization you did, how much energy you spend. They are not interested to go into keep track of all the metrics we come to collect. We collect, for example, a simple Prometheus agent gets hundreds of parameters. Some are relevant. So the tool should be very easy to use. Give them enough information if they want to go and get more information. That was the idea. And at the same time, whatever we give the dashboard should be reproducible. We should persist the experiment record of the energy measurement, whatever we did, and store it someplace. And if someone reproduces the experiment, they can go and compare how much energy they spend from the same workflow on their research infrastructure. So these were something specific requirements we try to address the dashboard. So what it does is we have a notebook. So within the notebook, there is a plugin with the same notebook interface. So they don't need to switch to a different web service or different endpoint altogether or different application. It's within the same environment. They can open a plugin with the same UI of Jupyter and see all the metrics. So it collects all the job record, the ground truth of using the monitoring agents and comes back and creates a high-level KPIs and gives you a dashboard to visualize. And we also store a record within a reproducible format. I will introduce it in a bit later that others could directly run the workflow or just keep track of what happened with this particular experiment. Both can be done. They want to either reproduce or check the logs of the data we collected. These features are implemented. Others we have development will be introduced in a bit later. Okay, so as an architecture, it is right now available as a Python package repository. Like if you are having the Jupyter notebook, you can just install it as Python, the Echo Jupyter tool. It gets installed the dashboard into your own notebook. Then you can start using directly on a tutorial that runs on. You can run initially to embed this dashboard within your Jupyter notebook. How does it work? We have a backend in virtualized environment, monitoring agents, Appendray and Prometheus. We export it, the data. We have ILL API as well as Grafana panels. And if you have a notebook, you fetch the repository and install the plugin. And these things are packaged inside your pod, the Jupyter pod. So you don't need to do any extra installation except installing the package. And you could do a couple of steps, install the monitoring. We have simple GUI to use it. As a user, if we update any new features, we just need to pull the new Python package repository. So it's easy for installation. The current feature is we keep track of low-level metrics and create some high-level KPI suggested by the Green Software Foundation you talked. They have some standard high-level KPIs suggest where people can compare between different software and use that high-level KPIs. One of the important aspects is to keep track. All the monitoring agents give a session metric, like every 5 minutes, every 10 minutes. What really required for the dashboard is to keep track of per experiment. Like if I run a workflow, all cells together, we should keep track of the energy spent on that particular experiment rather than just whole session. So because other people could also keep track of their experiment-based energy spent. And we push, let's say, keep the record as well, along not only the dashboard, there is the offline self-hosted database that keeps a record. And the same record can also be pushed into some persistent database management infrastructure. Our project partner, So Big Data, has the federated data management infrastructure. So we push to their database. So we also persist this reproducible artifact if required. Okay, so internally, how it works, same Jupyter Lab server might be serving a number of users because it's a virtualized environment, and we have to keep track of resource footprint of individual workflows. For example, we can have 3 people log in to the Jupyter server, and each of them spawns their own monitoring lightweight event, which is a stuff and rate, and we collect them for each of them and push it to their front-end API. And both of the APIs collected with the RAPL, and they have their own endpoint for people to use it. For implementation perspective, it is straightforward, nothing fancy inside it. So how does it work? This is just a high-level screenshot. We have a tutorial notebook, then we have real-time metrics. You can keep track of just like any public event. We have tons of, if you want to dig more into every feature, what happened with CPU, network, memory, that you could, of course, do with the Grafana panel. If you also high-level KPIs, there's a requirement you could add high-level KPIs, for example, HCI, it's software carbon impact and some other metrics we have at a high level. And we also exporter, which, as I said, it allows you to push the data into some persistent database. So what KPIs we are capturing? Software carbon impact is the standard adopted by Green Software Foundation. A lot of people are adopting it because individual energy consumption, carbon footprint, they are all good, but when you move across different software artifacts, we need a common unit that can be compared with a different workload, different infrastructure. What it captures is a total, let's say, environmental impact with operational emissions, like real-time energy consumption, like other people have shown, you multiply carbon intensity. So that's our operational footprint, energy multiplied by carbon intensity. There's a large fraction that comes with embodied. This is a development area. There is no standard to how to keep track of embodied. There are different people have different suggestions, but the current way is we keep track of spec. You take a server spec, estimate a lifespan. Okay, this has a 3-year lifetime. If I use for 1 hour, you take a fraction of it and add it. So we are just relying on static numbers for it, but there is an opportunity to make it a bit more dynamic. We also keep a per unit HCI but the idea is to collect low-level metrics like energy and utilization and give a high-level KPIs for users. For our domain scientists, they easily understand KPIs better than metrics. Okay, so coming back to the metadata exporter, whatever artifact we have, the metrics we collected, we make it as a row crate object. The row crate helps to create a reproducible experimental object. So we keep track of experiment data and associated artifact, then make it as a research object, metadata object, and push it later to the data management. It does have the metadata file, the JSON, some logs, and some details about the environment which we need to execute, and the main workflow itself. And this is not a mandatory. Some people want to have some extra data about life cycle analysis. We could also add it to this object. So this is after the dashboard creation. It is not part of the dashboard itself, but once we show the metric, we create this new object as well in the as an output. Okay, so maybe I will just show. I don't promise it will work because live demo is always a tricky. If it doesn't work, I have video, I will play video. Yeah. So this is a Jupyter notebook. So we have an example tutorial, some widgets that need to install initially. I'll go a bit slowly because it needs. Yeah. So this is the only package we need to install. Echo Jupyter, it pulls its public Python package, pulls it and installs it in your own. Yeah. Okay. So this got installed. Now just need to refresh because the dash plugin need to be. Now we can open the plugin. This is once we install that package, it loads the plugin inside your Jupyter environment itself. So this is the plugin that has some high-level KPIs and some detailed metrics if you want to keep track. Right now, we don't have any workflows running, so this is an initial dashboard. So this is, we kept it, it can be automated. We didn't do it. We kept this panel just for users to visualize what's happening in the backend. They can just click a button and install all the monitoring agent. There is also a possibility to make it automated. Yeah, so now you have a simple buttons. In the backend, it installs all the monitoring agents. So you install Python package, and you install the agents that are required to be installed within your own environment. Because some people might want to change the script and install a different version of Scapendre. They could do it here inside. But right now, we install the latest version. Yeah, so I install. This one takes a bit time. takes around 34 seconds. More because it's a live demo. If everything works as expected, it won't be a demo. Yeah, because I think it was cached. Like if you install first time and reinstall all the packages are cached, we would take the server. Maybe. Yes. Right. Yeah. Meanwhile, if you have some questions.
So this component installed inside the notebook and access to the replicating component.
Right now, we have installed within the pod, but the other version is running as a sidecar. But that requires a lot of configuration. For install as a sidecar, we need sudo. So we talk we know from here. Integrating potentially one of the API server. To run just as a inside agent to be tested, we don't need a sudo. We get a we can read from existing previous. But to run with that sidecar, we need some tools. That is the difficulty of completing. That's great. Okay. Yeah. Now we have example workflow just to stressing the. This is just a part of tutorial. It's not any serious workflow. You can try to stress the CPU memory for a different load. Let me do this. This one. So I stress the CPU and I can immediately go back to my dashboard and collect the metric. Yeah. So this takes the per experiment metrics. You can also have a previous experiment record. You can select which experiment. We track the experiment ID and print in your notebook at the end of it. And then you come back here and check per experiment metrics what happened. So we have some high level KPIs. Just the standalone value doesn't really mean anything. But when you compare across different experiment, different configuration, they give a meaning, which is less, which is high. But if you want an absolute metrics, so we also give all the panels. You can get a CPU, memory. These are not track based. It is directly from SCAP and reagent. So this is more like a low level metrics. For example, I want to see a power consumed. You want to have a CPU. Those we could do part of them. CPU, yeah. So all the individual metrics you could do, but high level KPIs are also there. We are in under development of this prediction as well. This is more about, okay, I have a federated research infrastructure. Before running, I have 4 research infrastructure in my disposal. Can we show them if you run on RI1, your SCI will be this, RI2, SCI2 will be this. For that to happen, we have to run some example benchmarks, collect some data. So this is not integrated yet, but so the idea is to change the behavior of scientists who use infrastructure before launching their workflow that might run for hours or days. they can see which RI is more efficient and execute. And at the end of experiment, they also have a ground truth. So how far they are from prediction and how much is coming to help them change behavior. That's an idea. Okay, so we have the actual some serious workflow from IceNet. We also tested with this. It was one of the workflow donated by EGI. So this also will do the same. You run a workflow and keep track of all the high-level KPIs and metrics. Any questions or anything?
For the experiment.
Oh yeah, I forgot.
Which format is the local database or the actually locate?
Right now, it's local. For example, this one, we store some metadata, experiment ID, start time, track, all. And we also have the detailed metrics. If someone want to see, because these kind of metrics are usually not exposed to the domain scientists, right? Like you have whole metrics of resource consumption. This is part of the tool. The row crate export is part of this main metadata, but we are waiting for the authentication token from SoBigData. Once we have, we push there. So it is stored part of your own workflow. If you want, you push it to the infrastructure persistent database as well.
Now is the
This CSV, but this one I showed, we are extending this to row crate. That feature is there offline. This one, we are making it as a row crate object, but this is not in the format of row crate. It is. Okay, so
let me ask the helpful question. Is anybody ready for this level of developing this tool and potentially using what's developed? Not yet.
actually, I met someone yesterday from Galaxy community. They have similar.
Galaxy is yes.
Yeah, but
You
not
need to talk
specific to Jupyter or one of the job they have developed. So I
But in this case, my question, what kind of thing shown by David Ritter, where they can show what's the
yeah.
powerful by the job. So you have similar. I think now. Maybe. Well, I don't have basically. This help because we need this to first of all share to gain experience and to find what we need to arise from how we can improve it. Yeah, well, I would say, well, then it's a view is also on to make something like this control and our well, without the well, actually, I'm talking to some yeah, but well, now I was looking with all you can do a big one to do that. An overview of this, and I will talk about very some protection stuff. Different between these people and that makes me like those are what will be great. Okay, so in the right tonight, but tomorrow will be here. Okay, yeah, I mean, great. You come here. It is the right point. So maybe I'll come with know, power to, so we find a way how to get it right. So I it's for me, we created that to put some of you to give us add-ons. And what we also do some stuff, previously, these two, trying to go, okay, 4 needs to go make spaces.
It's there in 2 minutes. I will talk about it. It's not done. Yeah. Maybe I'll take 2-3 minutes and finish this one. Yeah.
Okay. Would be looking for way of integrated all the or tools in the payment form of information model. The spaces with a lot that each project defines their spaces, they project one. The floor or the underscore and all methods. After that, we say database developer. They use methods that generate developer.
Yeah.
Explain.
Yeah, let me finish. Otherwise, I'm afraid I will break the promise that I will finish before 5. Okay.
I thought it was already inside the computer.
No, I have few slides. Yeah. So we are this is only for Jupyter. We have got access to the cloud environment. So we are planning to, because every type of workload has a different challenges and different features required. For example, cloud environment will have a long-running virtual machine. There we might need a different form of showing the metrics. It's not experiment-based, it's more about duration-based. So they run for a month, 1 year, where we plan to extend that and also add this prediction tool, because ultimately, if it could predict beforehand, that will change the behavior, which RI to select based on this dashboard. So that's an idea to be integrated part of it. And the part of other tools we are trying to adopt far under the project, not sure how far we will be integrated into the project going ahead, but we are trying to introduce a namespace for metrics collection, because sustainability metrics are quite complex. The utilization of energy, water, carbon. There are some metrics at site level, some at data center level, some at experiment level. So it's a wild west of metrics. So it's not easy to manage the monitoring database without really having the common information model among all the participants, or let's say So if you have this common information model, it becomes easy for researchers or developers to build a more reproducible software on top of that, where everyone has to write their own custom software. So that's where the namespace helps. It can be at a different level. For example, why we need a namespace? If a researcher want to compare the utilization between 2 different RIs, so how do they keep track of? One RI say the CPU usage, other RI say the CPU load. Although it looks very technically trivial problem, but when it comes to the real implementation, it creates a lot of overhead for developers. How do you keep track of different metrics in different RIs? What if we have the same namespace for each of the metrics and everyone adopts, let the database be there in their own schema, but in the hypervisor layer, or let's say adapter can translate between namespace to their database. It helps researcher or operator or even policy maker or even engineer or some AI model wanting to access the different servers based on different metrics. They could leverage such an for example, if it is a project specific, you can start with higher level prefix, or if there are some standards, there are already standards for carbon and high level KPI. We could start with their own namespace and divide the categories based on different levels. The category could be infrastructure or experiment or different levels. And it could also be based on the interest of the metrics we want to capture. But we can start with, this is a green chip metric, or all the metrics related to energy can go under this. Someone wants to keep track, okay, go and get the metrics with energy, and the database should fetch all the relevant energy related metrics, sub-metrics from it. Now I want only the efficiency metrics, what was the total runtime, You go and fetch from this. I want to know for my experiment period, what was the water footprint. So you mention the namespace and under the hood, you get all the low level metrics and get back to the user. So this would streamline everyone's life if you have standardized way of interacting with database. And this was an architecture proposed part of Green Digit that we want to give all optimization or effort we want to do at a 3 level. One is at an site level, one is at a middleware level, one is at an application level. You could also have an namespace at individual, for example, site level, you want to get carbon intensity at site 1 or site 2. So you get all the metadata of that site and use that site data for maybe the scheduling purposes or different other purposes. So if you want particular server level, you could also multiplex to the node level, or you want to track all the data about, for example, I shown we are keep tracking of experiment ID. How experiment ID means something for this tool, but what it means for some other person, some other tools. So how do they access it? So we can say, get me all the HTC job experiment record run on this site. So this would help to retrieve such a namespace. Okay, so with that, I kept promise and finished 1 minute.